Hi, my name's Jocielyne, and I'm here to talk your ear off about gallium. Gallium is part of Group 13, Period 4, the boron family. Gallium is a soft, silvery post-transitional metal that was first discovered by a French chemist in 1875. He discovered gallium in sphalerite. Gallium is not found in nature. It must be extracted from ores. Years before the actual extraction and discovery of gallium, the Russian chemist, the father of the periodic table, had actually predicted that this element was missing and that one would later be found. He did predict that the element would be similar to aluminum, but he did not predict the unusual properties that it would have. Gallium is actually solid at room temperature, but it has a melting point of 85 degrees Fahrenheit. This means that it will melt in your hand, but unlike mercury, it's not toxic. Gallium also has a boiling point of 4,400 degrees Fahrenheit. This gives gallium the longest liquid phase of any other element. This also makes gallium a great candidate for high temperature thermometers. Gallium is also used in pharmaceuticals, dental alloys, transistors, but it's mainly used in the electronic industry for semiconductors and light emitting diodes. What I found most interesting while doing my research on my element is how gallium has changed the world of lighting. The first incandescent bulb was patented in 1879 by Thomas Edison. Incandescent bulbs work by electrons bouncing off the filament, and then the atoms that the filament are made out of actually start to vibrate, which causes heat, and then the heat is used for light. While scientists for many years worked to improve the incandescent bulb, it actually still puts off 90% of its energy in heat. This could be a good thing if you're using the light bulb for your pet lizard, but in most cases, this is not the best use of energy. I'm not trying to knock Thomas Edison, but yay for LEDs. Gallium is a huge part of the LEDs that we use today, and I'll tell you why in a minute. LEDs work by having two layers. One has extra electrons and the other has extra positive holes. So when these electrons drop into these positive holes, they release their energy in the form of photons. Light! While other elements can produce light this exact same way, gallium is the one that is solely responsible for white LED lights. So the ones that we use in our house, headlights, street lights, none of those would be possible without gallium. The scientists that actually discovered how to use gallium to make white LEDs did win a Nobel Prize. LEDs are more expensive, and some people prefer the softer glow of the incandescent bulb, but they have many advantages. First being they barely put off any heat. Second being they last around 25 times longer. One of the reasons being they're more durable, they don't have things that are gonna burn out or break. And last, the biggest one is they use 75% less energy. An incandescent bulb will use over 200 million joules in its lifetime. That's about 3 tons of coal. So white LEDs are helping to cut greenhouse gas emissions. So think of this the next time you're out buying Christmas lights this year or changing a light bulb in your house. And another thing that I found really cool is that the process can actually be reversed, and that's how solar panels work. So the sun comes in, you have 2 layers of semiconductor material. The N-type is doped with an atom that has 1 extra electron, and the P-type is with an atom that has 1 less. So they're gonna find the holes. When they do, they create an electrical current, which is then taken and used for electricity. Gallium is used in solar panels because it has 1 less electron than silicon, which there are many other elements that have 1 less electron as well. But gallium has proven to be the best because it does not bond with oxygen and cause damage to the solar panels like they have found that happens with other elements. And gallium is being used on Mars right now in the rovers. Gallium, lighting up your world while it helps save it.